Ahead.
Thank you, Seth. Good afternoon. My name is Jim Sharkey. I am with EPRI. Today we're presenting the last of 3 webcast sessions on circuit breaker maintenance. If you are participating in a group session, please forward the names of those attending to Tanya Holt at THOLT@EPRI.com. That website or that email address for Tanya should be coming up on your screen here shortly. For the purposes of CEU credits, there will be an optional quiz at the end of each session. The quiz is 10 questions long. It's multiple choice and true or false. And all answers will be covered in the slides presented. Again, the test is optional. If you don't want CEU credits and simply want to participate in the quiz, you can do that as well. To request credit for CEUs, contact Tanya Holt. Also at the same email address, THOLT@EPRI.com. We will review all answers immediately after the quiz. All of this webcast material is posted on the internet at EPRI.com. The answers to the questions for this session are not posted yet, but they will be shortly. Tomorrow, I believe. Yeah, tomorrow. Webcast purpose and scope. This webcast discusses circuit breaker construction, operation, maintenance, and safety. The emphasis is on maintenance. This material was designed for power plant staff with limited knowledge on circuit breakers and circuit breaker maintenance. If you are a veteran circuit breaker overhaul technician, you will likely be familiar with many of these topics. This course was originally designed for managers or other plant staff that may not be familiar with breakers or breaker maintenance. The objective of this course is to raise the level of knowledge and understanding of the purpose, construction, and maintenance of circuit breakers. The scope of the course is limited to plant distribution type circuit breakers. Of course, the last 2 weeks we discussed breaker basics, the components. On session 2 last week, we focused on maintenance, the PM tasks, overhaul, special, optional, and other tasks. For this third and final session, we'll be talking about switchgear and cubicle maintenance and safety considerations. Being that this is the third webcast, I would like to encourage y'all to provide feedback to myself on both the content and the operation of this webcast. We encourage your comments and constructive criticism. If you wish to send in comments, please forward any comments you may have to myself, Jim Sharkey. My email address is jsharkey@EPRI.com. That's jsharkey@EPRI.com. Again, just to introduce myself and Gene Langlois, I have experience as a Westinghouse main generator field engineer, also a fossil plant maintenance engineer, and I have 13 years with EPRI sponsoring the Circuit Breaker Users Group. Gene Langlois is from Waukesha Electric currently. He's got 8 years U.S. Navy aviation support and 15 years of overhauling circuit breakers and switchgear. He's been with ABB, Grand Eagle, and currently with Waukesha Electric. The session today is going to be switchgear and cubicle maintenance. Gene is going to be covering that first, and the second section will be on safety considerations, just an overview, and we're going to be I'll be presenting that. So, moving on to session 3, part 1, Gene Langlois.
Thank you, Jim. I'd also like to thank all the attendees for joining us as well. And just to let you know, we may be covering some of these slides quickly or not at all. So to get started, what I'd like to is talk about what is switchgear. IEEE has a basic standard which states that switchgear is a general term that covers interrupting devices and their associated control metering and protective devices. Switchgear consists of assemblies of these devices with their associated interconnections, enclosures, supporting structures used primarily for the distribution of electric power. And on your screen right now, you'll actually see a lineup, and you're going to see here we have a transformer. On the other side, we have another transformer. We have main breakers coming off the transformer. And in the center, you'll see a tie breaker that is opened and racked out. And we'll also see some meters on both sides above the mains. All switchgear has circuit breakers, a metal housing, bus, and insulation, or insulators. Note, during cubicle and switchgear maintenance, you should not work in cubicles with bus or bus tabs energized. And here we have a single cubicle switchgear that is divided into its compartments. First one we have is a circuit breaker and instrumentation, and that typically would be in the front. Then we have the bus compartment. On some lower voltage and most medium and higher voltages, this bus compartment cannot be seen. It is protected by a steel barrier or an isolation barrier. And then the last one we have is the cable compartment, which is normally in the back of the cubicle. So if you open up the back of the cubicle, you would see the cable compartment, but not necessarily see the bus compartment. We're going to get back to actually looking at the switchgear in a minute. Right now I'd like to talk a little more about lubrication. The manufacturer recommends lubrication is what you should use unless you have justifications for changing it. Some of those reasons are some manufacturers throughout the years have actually changed the lubrication that they use, and you should follow that. And if you have multiple vendors or manufacturers in your plant, then you need to take care and caution not to mix the lubrication between each other or other types of manufacturers on their equipment. And here we're just not going to actually read these, but here are some of the list of lubricants and some of the compatible and incompatible properties about them. And we'd like to take a look at the last one, penetrating oils. One thing that you want to keep in mind about penetrating oils is they contain solvents. So they may act as oils for short periods of time, but then the actual solvent will evaporate out. And the idea here on this slide is that you must know and control the lubricants you are using. You don't want to mix them, and if you change the lubrication you're using on the breakers, you also want to make sure that you pay attention to the old lubrication that is in the switchgear. But some other notes about lubrication you need to keep in mind. Two things. One is the shelf life. We have a list of items that talk about some of the things you need to pay attention to. And also, one of the properties of lubrication, or bleeding. If you open up a new can of lubrication and you find that it actually has started to separate, that particular lot may or may not be good. And roughly, if you see 10% of bleeding or separation, you should reconsider not using that lubrication, throwing it away and getting a new container. And that ends the basic switchgear definition and a little more on lubrication. Now we're going to take a look at the terminology of switchgear, bus, and cubicle. We spoke about switchgear, and we spoke a little about cubicle and bus. The cubicle is normally found, as stated, in the front part of the switchgear. Controls the interlocks, breakers, and the instrumentation. The bus is usually found in the back compartment or the back door. When you open it up, you may or may not see all of the bus. The very first thing we're going to take a look at is we have bus and cubicle. And we're going to take a look at cubicle first and bus in a minute. We're going to divide it up into three things we're going to do. First thing we're going to do is we're going to do inspection, then we're going to clean, and then test. We have a list of items, and during inspection phase, if an item is found, like a cotter pin or oil, inside of the cubicle floor, you may want to stop and do more investigation as to where that piece, part, oil came from before continuing on with your inspection. After you do that, we're going to take a look at the inspection. You're going to want to look at the control wire for cuts, nicks, bad crimps. You visually inspect the components for damage. Inspect the shutter for smooth operation, that it opens completely and closes completely. The interlocks, some may require you to make jigs to check for height and or use the breaker to verify it's operable. Check the fuse blocks, broken welds. You want to inspect for loose, broken hardware, and check and adjust as required. And now, when you're doing your inspection, one of the things you want to take a look for is moisture and ventilation. You want to inspect for unnecessary floor openings, signs of moisture accumulation, and you want to prevent moisture accumulation by providing that the heaters and fans work properly. And when we get into testing, we'll take a look at how to properly test or inspect them. And you want to check for ventilation, that it's clear and there's no obstructions. Cleaning. You want to vacuum or remove by brush or wipe down with a rag to clean any dirt, dust. You want to check and adjust any item that could not be checked or adjusted during the inspection phase. And again, do not work in a cubicle if it is energized. After you get done cleaning, then you're going to want to test. Cubicles should be tested for the protective devices, the interlocks, and you can do insulation resistance or measuring, and low resistance measurement or ducting. And then you want to take a look and test the heaters, and we have several ways that you can test them. If house current is available, you can actually plug them in, turn them on, and see if they heat up. You may come across some that actually have thermostats, and you may have to adjust the thermostat up and down to verify if they work. If it does not have a thermostat, and you are unable to actually get to house current that you can use a volt ohm meter and look for opens and shorts in the wiring. And generally, as a rule of thumb, you would expect that the heaters would be within 10% of each other, and you'd use basically the same for checking for fans. More on testing. Insulation and conductivity, the cubicle and breaker frame. This test requires both the breaker and the cubicle. And what you're actually checking for is racking the breaker into the cubicle and seeing where the ground clip mates to the cubicle. And you're going to check to make sure that the contact between the two gives you a low resistance. And when you're actually checking the frame to frame, or frame of the breaker to the frame of the cubicle, you do not want to check it to any painted surface. It can actually lead to a false reading. That pretty much ends cubicle. Now we take a look at bus inspection. And again, we're going to take a look at inspection, cleaning, and then testing. We'll start off with bus inspection. First thing we want to check is we're going to check the insulating or insulation parts. And we have a list. We'll look for splices, edges of the insulation, hidden surfaces, and such. The next we'll take a look at is inspection of the bus itself. You look at the bus joints, the edges of the insulation, again, hidden surfaces, adjacent edges, sharp edges, and we have more on the next slide. We're going to check for loose bolts, examine grounding connections, and we're going to check alignments. After we look at the bus and the insulation, then we'll take a look at the PTs, or potential transformers, and the VTs, or voltage transformers. You're going to perform a visual inspection to check for tightness of the hardware. When you're looking at PTs, or potential transformers, the performance can be seen by in-service by looking at the meters and verifying that they are accurate. And we'll be taking a look at CTs. If we look at CTs, you have to be careful because epoxy resin can liquefy over time. If you want to perform a visual inspection, check for tightness. You can perform a CT secondary wiring impedance and feedback test. The next one we'll take a look at is the ground transformer or ground CT. And one of the very important to keep in mind that even low current leakage may present a hazard to personnel. And there are two common types we have. And we're looking at a picture of one, and then we have a picture of another common type of a ground sensor. We take a look at cleaning. Basically, we spoke about it in session 2. Cleaning, you want to use the least aggressive method as possible. You either want to use a dry rag to remove dusts or whatever is on the insulation or the bus. If that can't be done, then you're going to use denatured alcohol. If you use anything stronger than denatured alcohol, you're going to want to go back over it with denatured alcohol and a dry rag to remove any type of residual. After you do that, then you perform insulation tests. You do phase-to-phase and phase-to-ground, pretty similar as you do to the breaker. And then you want to compare those values to what is either considered expected or if the manufacturer gives some sort of values. And keep in mind that temperature and humidity will play effect in your values. And the last thing you want to do is inventory your tools, jumpers, and equipment before you close up the cubicle. And that ends bus maintenance. And we're going to start to take a look at some specific problems to the breaker that may lead to an indication that you have a problem within the switchgear itself. This particular breaker was overhauled about 4 years previous to removing it from service and finding some of these problems. And what we're going to take a look at here is you see it says heat damage where it has a white right around here, around all the upper stabs and the lower stabs, where the red glassing is literally was so hot that it actually turned that insulation white. We removed the primary disconnects and found on the upper 3 leads hard lubrication. And if you look here on this finger assembly, you'll see that one of them is actually black in color, where all the others are silver. And we'll be taking a look at those in another slide here in a moment. And in the very bottom one, you'll actually see like a sputtering contact where it actually looks like you could actually see the copper underneath, and it was very jagged. Looks like somebody had pitting. Thank you. All right, we'll take a look at these. Each one of these a little closer. Very first one to take a look at is lubrication. In this particular picture, you'll see where we have a yellow circle circled around a actual drip of a NOx, where it had dripped out of the contact structures and was actually dripping down onto the mains, where the contacts had received so much heat or built up so much heat that it caused the lubrication to actually liquefy and drip out. As it dripped out, you'll see that on the two particular bottom pictures, the lubrication, as the breaker opened, literally caught on fire and burned onto part of the main contacts. As we tore the breaker apart, we could see specific problems with the insulation material. Overheating of the insulation, where the actual arc chute bolts to the upper lead, more hardened lubrication, and the back parts where the insulation material around was actually broken and brittle. And here we have a closer look at the over-lubrication, where it had dripped onto the mains. And a close-up. And you can see where we had, in the very top one, we had ionizing or splatter. And again, where we had arcing with the breaker opening causing a burn. Now normally, in the normal state, we would see that the arcing contacts will reset themselves. On this particular breaker, you can see the middle set of arcing contacts did not reset, or actually push back, and they had locked themselves in that position, caused by the hardened lubrication drying out. We started looking at the primary disconnects. Again, we could see where you had splatter or pitting effect on the primary disconnects. That led us to look inside the cubicles. And when we started looking inside the cubicles, we took them apart, and we found hardened lubrication on the bushings, loss of silver plating, greenish substances, and overheating as well. We removed the bushings and found that over years they had used an abrasive pad, and they had literally removed all of the silver plating, leaving bare copper. And when we pulled apart the actual bus, we found hardened lubrication on the bus and damage to the insulation material. Now, when you get to this step, by taking apart the bus, as you'll see in this particular slide, if you start to look at your bus and disassemble it, it's kind of a good idea to expect the worst. Because as you take it apart, many times I've found that you create problems. And the last thing we saw with specific problems was any of the boots, rubber, nylon parts had cracks, splits, or when they were being removed or taken apart, would fall apart or break. And that also went to the insulation of the cables, that we actually had them, as you pulled them off of the bus, the actual insulation would actually split and crack. It was brittle as well. And that ends specific problems and challenges with the cubicle and breaker. And that, I'm going to turn it over to part 2. safety considerations, and we turn it over to Jim Sharkey. Jim?
I think, doesn't NETA have a standard on, or a standard on switchgear maintenance? NETA, if you're not familiar, National Electrical Testing Association has some guidance on inspection and testing of switchgear. If you're interested, their website is, and I apologize, we should have put this on a slide, but it's www.netaworld.org. That's netaworld.org. They have some guidance on inspection and testing of switchgear. This next section discusses switchgear, or excuse me, safety. We only have limited amount of time. Electrical safety is a huge topic, obviously. We're going to just give an overview during this presentation, during this webcast. We broke it out in this section. We have a management's role. Management has a key role in electrical safety, obviously. We have equipment safety and design features, where we talk about interlock, shutters, keyed locks. Then we move on to safe work practices. This can be broken down into policies and procedures, work management processes, plant and utility safe work practices, such as voltage detection and so forth. And then you just have personal safe work practices. Another major category would be tooling and equipment. Personal protective equipment, as far as working on breakers, there's lifting devices, work platforms, spring blocking, and even chemicals. So we're going to talk about a little bit about equipment maintenance, and then finally we'll end with arc flash safety. Of course, obviously everyone knows this, but it can't be overemphasized. Safety is paramount. If you cannot do the job safely, don't do the job. I was at just recently I was at a plant, and they had a sign posted on the front of the training center saying, "No job is so important, no schedule is so important that you should sacrifice safety to get the job done." And of course, everyone understands that. Management and leadership oversight. Company and plant management involvement is essential. Management should establish expectations on safety. Key management roles: establish and maintain procedures, provide appropriate PPE, and promote a workplace culture, which is very critical. As far as policies and procedures, of course, company and plant safety policy should delineate expectations. Procedures should provide specific instructions for safe work practices, including lockout, tagout requirements, proper use of test and grounding equipment, use of PPE, that's personal protective equipment, worker-specific cautions, limitations, guidelines, voltage detection practices, even as far as human performance techniques, error reduction, and so forth. Approach boundaries and cautions. This deals with arc flash, which we'll talk about at the end of this session here. Voltage detection, we mentioned, dead live checks, and even contractor control is a part of electrical safety. Work planning. We're talking about work management processes. Work planning should consider electrical safety. Any potential hazards on an electrical job should be identified and accounted for, including that identification of potential energized sources, things such as backfeeds, potential PTs and CTs. Pre-job briefings and walkdowns should verify potential energized sources, identify and verify potential energized sources. Voltage verification, establish approach boundaries, use of barriers, PPE and tools, things like jewelry, is jewelry removed, and discuss two-person rule if your plant has this. Now we're going to talk a little bit about safety features such as interlock shutters and keyed locks. On medium voltage circuit breakers, typically what you have is a thing called shutters. Or I think most, if not all, medium voltage breakers have shutters. When the breaker is lowered and racked out, these shutters close to prevent inadvertent exposure of personnel to any energized staff. On low voltage switchgear, 480 volts and such, you have bus covers that can either be provided by the manufacturer or can be purchased or even fabricated. Bus covers such as these used on low voltage prevent technicians from coming into contact with live bus during cubicle cleaning. I do realize we have a question on getting into the cubicle. We'll try to address that toward the end of the session here. Moving on to interlocks. Interlocks, and we covered this in session 1, but I don't think we really defined what interlocks were. Interlocks are mechanical locks that prevent the opening and closing of a circuit breaker when doing so would be unsafe. And this was really paraphrased from an IEEE definition. Common interlocks prevent the breaker from being moved from a connected position when closed. Also, there's another interlock. There could be various interlocks on breakers, but there's a minimum as defined by IEEE. Another one is breaker being closed unless in a fully connected or a test position. Before installing a breaker in the cubicle, ensure the breaker is open and springs are discharged, and perform a visual inspection of the breaker before installing it. And of course, your routine PM procedures should verify the operability of all interlocks. We discussed that last week. Keyed systems. It's very important to ensure proper control of keys of keyed systems. If you have duplicate keys, they should be put in a safe place and only accessible to authorized personnel. I couldn't help but put this picture in the presentation. I love this picture. But this is just an introduction slide to safe work practices. Of course, again, to reiterate, safety is paramount. Prior to switchgear work, ensure that the internal bus is properly electrically isolated and grounded on all three phases. All electrical backfeeds, including potential transformers, must be identified and electrically and/or physically isolated. During a bus outage, do not assume that all cubicles are completely electrically isolated, even during a bus outage. Bus feeder and tiebreaker compartments may be energized. Any breaker cubicles containing energized sources should be locked and or barricaded prior to maintenance. Components should be considered energized until electrically isolated and tested, very critical. When entering switchgear, be aware that control circuits and heaters can be energized. This is typically, maybe during a PM. And this is slightly redundant. Gene's already mentioned this several times, but of course, during cubicle or switchgear preventive maintenance, do not work inside a cubicle with bus staffs exposed. Obviously, if the bus is live, during a bus outage, you may be working in there, but if you have a live bus, and for whatever reason the bus staffs are exposed, you should reconsider that. If possible, de-energize the entire cubicle, including control power. just safe work practices, removal of jewelry, metal eyeglasses. Of course, the use of insulated tools. Most plants have these electrically insulated tools. And we're going to talk about flash protection boundary here in a little bit. Continuing on with safe work practices. Access, if working on an energized switchgear with an energized feeder, access to the feeder or bus conductor is physically locked, barricaded. I think we already went over that. Use of physical barriers such as rubber blankets can be used. Remember, everything is live unless proven de-energized. This is an ideal time for peer check. You can verify both AC and DC. You could use a minimum of two-step process to ensure the circuit is dead. Verify correct circuit is de-energized and tagged out, and use dead live checks. Two-person rule. Many plants follow this, and it's pretty much self-explanatory. A safety observer can ensure that the applicable rescue equipment is immediately available, ensure adequate communication mechanisms are available, and observe any safety issues. And of course, a safety observer can implement any emergency actions. This is just an electrical safety checklist. You may not be able to make this out. It's kind of small print. But this just is one of an examples of plant electrical safety that they've built in to their maintenance processes and procedures. It's a very valuable tool, an electrical safety checklist. This can be used in a pre-job briefing or reviewed at the start of a shift. These are just general factors to reduce the chance of an accident. This is just personal safety practices. Of course, knowing your limitations, no shortcuts, and so forth. Be aware of your surroundings and the possible hazards in your area, especially that guy on the ladder and in the pool of water. Perform all dead live checks. We've had a lot of questions through the years about asbestos. Asbestos is commonly contained in arc chutes. This is the air magnetic breakers, in both medium and low voltage breakers. You should be aware of the necessary safety precautions for your specific circuit breaker models. However, some plants have done their own testing because they've had a safety concern, and these plants, for some arc chutes used in the U.S., the asbestos contained in the arc chutes is non-friable, and these arc chutes can be safely handled without special equipment when performing routine PM tasks. Obviously, you don't want to take one of these arc chutes and run it over a table saw and cut it in half, because you would be putting asbestos into the atmosphere. Wouldn't be a smart move. So moving on to tooling and equipment. This is just some photographs. We've got some insulated tools and voltage detected devices, hot sticks, and so forth. Personal protective equipment can be used, includes flash hood, face shield, gloves, a jacket, and hot stick. Again, with equipment, spring blocks can be used during maintenance for capturing closing springs. You should always know the status of the closing and opening springs, whether they're charged or discharged. And if you can use something like spring blocks, if this would prevent an accident and possibly prevent somebody from losing a finger. Now, I put this slide in here. I feel rather strongly about this. When you think of safety, most people don't think of the maintenance program as a part of safety, but I feel very strongly that it is. Even though it's not normally considered a part of a safety program, it is fundamental. If you think about it, properly maintained equipment will prevent accidents, especially in the case of circuit breakers. You know, if a breaker fails, it could be catastrophic. It could explode, and if someone's in the switchgear room when that happens, that would not be good. Moving on, this is the final section. We're going to talk about arc flash. Just going to hit the highlights here because we're limited on time. And an arc flash, trying to define what an arc flash is, it's basically substantial current passing through ionized gas. It's extremely high radiant energy, extremely high temperatures, up to 40,000 degrees F, 22,000 degrees C. It's explosive in nature. When you have an arc flash, the initial expansion of the gases during the flash initiation creates a blast, an actual explosion. This can ignite or melt conventional work clothing and cause severe or life-threatening burns. The exposure energy is measured in calories per square centimeter. After an arc flash safety analysis is performed, that's usually the end result. An arc flash results in radiant heat energy, molten metal, sound pressure, in other words, a blast and a pressure wave, and shrapnel. Picture is worth 1,000 words, I always say. You have a shock wave, could be up to 2,000 PSF, a radiation wave, infrared, UV, up to 50 caliber, in this case, 50 calibers per square centimeter. It's got a 165 decibel there. That's the sound of the explosion. You have copper particles, shrapnel, any metal around the area. Once the explosion happens, might be coming your way. So it can be quite an explosion. I mentioned arc flash safety analysis. This is an engineering evaluation that calculates the amount of energy available from each piece of plant equipment. Based on this analysis, proper personal protective equipment can be selected. This is kind of a graphic of the approach boundaries, the arc flash boundaries that are created, or that can be created as a result of one of these arc flash safety analysis. You have the exposed electrical hazard on the left, and to the far right you have an arc flash boundary, a limited approach boundary, and a restricted approach boundary. As you get closer and closer to the exposed electrical hazard, you get more and more restrictive. You have a definition of each arc flash boundary, going from on the top is the most restricted to the bottom, the least restrictive. The prohibitive approach boundary is crossed only by qualified personnel. It requires the same protection as if direct contact is made with the energized part. A restricted approach boundary is crossed only by qualified personnel and requires the use of shock protection techniques and equipment, such as voltage-rated gloves, insulated tools, or insulated test leads. A limited approach boundary can be crossed only by qualified personnel. Unqualified personnel may cross this boundary if escorted by a qualified individual. And then you have a flash protection boundary, and you have no entry without flash protection. when working on or within flash protection boundary of exposed energized equipment, you should alert the others of potential shock or arc flash hazards associated with your work. This can be done by posting signs, placing a barricade or danger tape to mark off the area, or using plant personnel to control the area. Such activities as racking breakers, working on or near exposed energized parts, and you should consider flash protection boundaries when performing equipment manipulations and working where exposure to automatic actuation of equipment can occur. I think this is an excellent picture. Again, a picture is worth 1,000 words. This is a sign actually taken at a nuclear plant out west. This is 480 volt switchgear, and they went through and performed an arc flash safety analysis and posted right on their 480 volt switchgear. If you look down right in the middle, there's PPE requirements, and it denotes the calories per square centimeter, which is an arc flash hazard, and the flash boundary. And it also delineates the voltage class. So this is a bus. This is kind of an end result. And that's really the end of session 3 and the end of the webcast. We're going to go over a few questions here. We've got at least 2 questions here, maybe more. And looks like Gene's chomping at the bit. He's ready to answer some of these. So we'll move on to the questions, and then after the questions, we'll take the short quiz and then review the answers.
We received a question that asked, which stated that cubicle maintenance should not be performed while the bus is energized. That is correct. Now you can clean and inspect a cubicle, but not perform maintenance, as long as, while you're doing your inspection and cleaning, you follow your plant's specific safety, PPE, and procedures. And the barrier is designed to protect falling and objects from striking the bus. So cleaning the floor would be acceptable, but cleaning the actual protective barrier would not.
So that's an excellent question. A lot of this is terminology. We mentioned cubicle maintenance and bus maintenance. Terminologies may differ at various plants, and obviously safety practices. You obviously want to follow the safety practices at your plant, and that varies somewhat. But when we were mentioning bus maintenance, I think what we're really talking about is if you have a bus outage and the entire bus is dead, and you're doing more detailed maintenance where the bus may be de-energized. Obviously, you can do more when you have a bus outage. When you're doing PM, just a routine preventative maintenance on a cubicle, a lot of plants, of course, allow cleaning and inspection and other tasks that are what you call minor. And like Gene said, any of these tasks, you really have to use your common sense. And if there's any chance that you could inadvertently come in contact with bus, you want to not do that. So, but again, safety practices from the various plants are a little bit different. But Gene makes an excellent point.
Okay, the next question we have is, what do you mean by creating problems when taking apart the bus? Some of the major challenges that we've come across when you do bus maintenance, it's fine, but when you actually when you do bus cleaning, you run into very few challenges. But when you start to perform maintenance or disassembly, many of the challenges I've come across were damage to obsolete parts and having a very difficult time being able to replace those parts. Hardened lubrication on bus, after disassembly, cleaning off the lubrication in some of the cases was impossible. And we literally had to take the bus, have it sent out, stripped, replated, and then to put back in the cubicle. We also ran into major challenges with plastic and nylon parts, where as soon as you took them apart, they would break and fall apart in your hands. And cable, the insulation. Some of the older cable, as it's installed and attached in the back of the bus, if you needed to get past that to look at the other section of the bus, once you disconnected this and you would pull the cable backwards or to the side, it was so brittle that it would crack, and we literally had to actually pull brand new cable because of it. So that is what I mean by creating a problem, is that worst case scenario, if you know you're going to go into the cubicle, you need to be able to address those issues, hopefully ahead of time. Know where to get the parts. Know what hardware you're going to need. Know what lubrication is on there, or who can replate the bus for you, and can they turn it around in a short period of time. Can you get the cable?
And typically with any type of switchgear parts, the lead time is usually pretty long. So you want to be very careful. And really, in theory, any time you go in and do any type of maintenance on any equipment, you can always have maintenance-induced error or maintenance-induced failure. So, got more questions?
We're also asked a question, what do you do if the silver is polished off of the stabs? Depends on your plant's policies and procedures. If you are, worst case, a nuclear power plant or something of that level, and it's important to know how many mils thick the tin underneath and the actual silver plating is, then you may have some challenges. You just may have to replace it rather than even try to repair it. And keep in mind that you may actually have to, if you're worried about the cable, go in and cut out the front part of the cubicle to get to it. Or, if you can, you go through the back, you can remove the stabs, send them out, and have them replated if there's no pitting damage. If there's pitting damage, then you may have to have those filled and then replated, which in most of the fossil fuel plants that I worked at is completely acceptable and do it quite often.
I think that's, is that it? I think that's it. Okay. Very good. Let's move on to the quiz. I would recommend that, well, first off, we're going to give at least, at a minimum, 30 seconds to answer each question. I would recommend you read all of the possible responses and choose the best answer. Are we ready to move on to the quiz?
Yeah, that's fine.
Do we have another?
We have 3 questions actually, but we're going to have Gene answer those directly.
Okay. I've just been told we have a few more questions. I think what we'll do, those of you who sent in some questions and we did not answer them, we will respond to you via email. There's some other questions I understand, but in the interest of time, we'll move on here. Seth, are we ready for the quiz?
Certainly, Jim. Anytime you'd like to begin.
Okay. We'll go to question 1, if everybody's ready. Get my little stopwatch out. I'll read the question and the potential answers. One way to prevent moisture accumulation in switchgear is by ensuring that the heaters and fans are working properly and the ventilation is clear of obstruction. True or false? It looks like we have about 30 people online, so I'll wait. Got about 2/3 of respondents so far. Okay. It's been about 30 seconds. If you haven't answered this one, I'll give you a few more seconds and then we'll move on.
Okay.
Oh, we got one more answer. Okay, ready to move on. Question 2. Ground current is blank, but still may present a hazard to plant and personnel. A low current, B, a low voltage, C, a high current, D, a high voltage. Okay, just 5 more seconds and we'll move on. Question 3, a test in which you need both the circuit breaker and the switchgear to perform is A, a high current test between the breaker frame and the station ground, B, the timing test between the breaker frame and the station, C, the resistance between the breaker frame and the station ground, and D, the test that the breaker will open and close. Still got a couple more people that haven't answered, so we'll give you all that. Okay, 5 more seconds. Okay, moving on. Question 4, equipment maintenance is not normally considered part of a safety program, but is in fact fundamental. True or false? Looks like everybody's answered that one. So we'll move on. Question 5, factors that can reduce the chance of an accident. A, work with a partner. B, know your equipment. C, be aware of your surroundings and the possible hazards in your area. Or D, all of the above. Okay, looks like everybody's answered that one. So we'll move on. Question 6. An arc flash can result in A, extremely high temperatures, B, vaporization of materials, C, a pressure wave, or D, all of the above. Okay, looks like we gave you guys an easy one there. Everybody's responded to that one, so we'll move on. Question 7. When working within a flash protection boundary, methods of alerting others of shock and arc flash hazards include posting signs, tags, placing a barricade or danger tape to mark off the area, and using personnel to control the work area. True or false? Okay, everybody's responded to that one, so we'll move on. Number 8, the testing of a potential transformer can be A, not required, performance is assured by in-service observations. B, tested by measuring insulation resistance, measuring only. C, tested by transformer turns ratio tester only. Or D, not tested. Okay, we'll give a few more seconds on this one. Okay, next question. Number 9, when should the consideration for electrical safety be identified and accounted for, including the identification of potential energized sources? A, during work planning, B, during pre-job brief, C, before the beginning of a shift, or D, all of the above. Okay, looks like everybody's answered that one. About to move on. Last question. When working with personal protective equipment, PPE, and checking for voltage, the best way is with appropriate meter is A, live, dead, live, B, live, live, dead, C, dead, live, live, or D, dead, live, dead. Okay, just a few more seconds. Okay, I think that concludes the quiz. Seth?
Yeah, Jim.
I think that pretty much ends the quiz. Can we move on to the review of the answers?
Certainly, if you'd like to go ahead.
Okay, we'll just go ahead and do that. So we'll close off the quiz. Question 1. One way to prevent moisture accumulation in switchgear. Oh, I'm sorry. There's a slight delay when we turn these slides on, so apologize for that. Okay, you should have question 1 on your screen. One way to prevent moisture accumulation in switchgear is by ensuring that the heaters and fans are working properly and that the ventilation is clear of obstruction. And that is true. It's a basic preventative maintenance task that you should have. Question 2, ground current is blank, but still may present a hazard to plant and personnel. Answer is A, a low current. Question 3, a test in which you need both the circuit breaker and the switchgear cubicle to form is C, resistance between the breaker frame and the station ground. Question 4, equipment maintenance is not normally considered part of a safety program, but is, in fact, fundamental. That is true. Question 5, factors that can reduce the chance of an accident. The answer is D, all of the above. Working with a partner, knowing your equipment, and being aware of your surroundings and possible hazards. The answer is D. Question 6, arc flash can result in. Answer is D, all of the above. Extremely high temperatures, vaporization of materials, and a pressure wave. Question 7, when working within a flash protection boundary, methods of alerting others of a shock and arc flash hazards includes posting signs, placing a barricade or danger tape, and using personnel to control the work area. This is true. Question 8. The testing of a potential transformer can be A, the answer is A, not required. Performance is assured by in-service observations. Question 9. When should the consideration for electrical safety be identified and accounted for, including identification of potential energized sources? Answer is D, all of the above, in the work planning, the pre-job brief, and before the beginning of the shift. Question 10. When working with PPE and checking for voltage, the best way is live, dead live. The answer is A. I think that pretty much rounds out the exam or the quiz, and that's the last slide. We have no more. On behalf of EPRI and myself and Gene Langlois and Tanya Holt, we appreciate everybody participating in this webcast. Again, I would encourage, if you have any feedback about this webcast, any constructive criticism, this is the first of these webcasts on circuit breaker maintenance that we've held. I would appreciate you sending me an email. Again, my name is Jim Sharkey at EPRI, and my email address is JSHARKEY@EPRI.com. And we welcome your comments. Gene, you have anything? No? Okay. Seth, that's it, and thanks everybody for attending. Thank you.
Thank you, Jim. Thanks, Gene and Tanya, for your participation today, and thank you, ladies and gentlemen. At this time, our EPRI event is concluded, and you may feel free to disconnect your lines now. Once again, we thank you for your participation today, and have a great day.
I'll close out this file.
Right on time.
Seth, are you stopped recording?